Alright guys, so in the Explore video we learned about this big race through the woods. So what we're going to do here is we're going to make a 3D model of that race. And we're going to do it by using pipe cleaners. So each of these different pipe cleaners, they represent a different runner. So there was 7 different runners that we had in this race. And later we learned that each of these pipe cleaners, they represent a different species. So we know that in the race all the runners started together. So we'll start by twisting the bottom of this together here. So each runner starts together, and as they go, we know that they kind of branch off. So as they go, this first one, they're all running together, and this first one kind of branches off. And the rest of them keep running together, so we'll keep twisting these together. And then they go a little bit further, and another branches off. So if you can see that, they've got these different branching events, and then these ones run together. So these different branching events or speciation events are going to be really important, and we'll talk about them more here in a minute. So as these run together, the next branching event we have, there's 2 that branch off. And these 2 run together for a little while. We'll twist those 2 together. It's a little hard to see while I'm doing it, but I'll show you here in a second. So these 2 kind of branch off, and then these 3 stick together. So far we've got these first 2 that branched off, and then we've got a little separation here. And then we see that the 2 of these separate as well. And then 1 jumps off this group. The other 2 run together for a while. And then these 2 end up separating here in a different group. So we'll see if I can lay this out good enough that you can get a good 3D image of it. So it's important to realize as we look at this model here that at the beginning we didn't start with 7 species all running. We didn't start with a trout, a salamander, cow, human, pigeon, crocodile, gecko. That's what we end up with after these speciation events. So as we see here, we can see these little strands and things and the spaces in the middle. All along those are all sorts of different traits that these develop, and that's kind of what separates each of these things. So this is all one species and it goes, and then because of different effects, because of natural selection, some of the species will develop different traits, and it will branch off, and then you keep going. So then now here we have 2 different species, and we can see each of these little nodes. I don't know if you can see them there. Each spot, that's a node there, that is a common ancestor. And so this is where the common ancestors are, and as they branch off, each is a new species form. So the very end of these is each a new species. So when we talk about those 7 different species that we have and that we're comparing, they're on the end of each of these. And as we want to know how related each species is, we do that by coming back to the common ancestor. So it's important to realize that on this model and in the picture that you have, that each of these little nodes or each of these little spots is the common ancestor. And that's how we find how each of these species is related, by going back to the most recent common ancestor. So as we want to know how this one here, how this cow is related to a trout, we trace each back to their most common ancestor. These ones both go back all the way to here, to this common ancestor. And you can do that with each of the different species that we have here.